this is a section on algebraic fractions. It's partly done just in case I am late back from the hospital, but I should be back in time for the lesson this afternoon. So far we've actually done some algebraic fraction work and simplified things like so we've done things like simplifying fractions where we have two fractions and we've got to find similar common denominators. So we get things like 5 over 6r plus 10 over 11s. And to simplify these down, what we need to do is put them into a form where they are on the same denominator. A simple way to do that is the lazy method. We're just going to multiply the denominators together. And what that means is each other side needs to multiply by the denominator of the other fraction. A lot of people will actually show a crossover when they're explaining this. So what I get on top is 55s plus the numerator on the other side, which is 60r, and all of that is over 6 times 11 is 66, and rs. We then have a quick look through and see if there's anything common that we can take out. There's only common bits on the top. There's no point creating a bracket necessarily. There's nothing common in the bottom. So that would appear to be completed. And so what we're going to look at is stepping this up a little bit, eventually going to quadratics. So I'll do a couple of examples. Things like if I've got 36 over 4b plus 32. Initially, it doesn't look like there's very much we can do to manipulate this. But then we realise that all these numbers are multiples of 4. If they're all multiples of 4, then we can factorise out of 4 to work through. So we're effectively saying on the top we've got 4 times 9. The denominator, we can take a 4 outside of the bracket, multiply it by b, and add on 8. Because the 4's now can be almost written as a separate fraction, because it's just one fraction multiplied by another fraction now. This fraction cancels down to 1, and we're left with our result, which is 9 over b plus 8. That's why it's important that you must be able to factorise it out. It must be able to create this fraction, which cancels to 1. Yeah, let's do another one with a bit of algebra in it. So we've got 24d divided by 3d squared, subtract 21d. Now we're looking through and we're going, well, 11, 21 and 24. That means I can bring out a 3. And notice all the terms also have d's, so we can take out 3d from each expression. The top part is going to be 3d times 8, and the 3d on the bottom is going to be a d to give us the d squared minus 7. I'm not going to show the cancelling again. Can cancel here and here to give us a result which is 8d minus 7. Okay. Step it up a little bit and go a little bit more complicated and do a couple of ones with quadratic denominators. So we've got m plus 2 to be shared by m squared plus 5m plus 6. And now we're getting to the point where things are looking a little bit more complicated. We can't look for these common denominators now. There's no common ones here. Now what we look for is, okay, can I factorise this denominator? And can I factorise it nicely? Well, the denominator of this one, by looking at the numbers, we're looking for 2 brackets, each beginning with an m for the m squared. We want numbers that will give me a product of 6 and a sum to 5. And the sum plus 5. So now we can put in product is going to be 2 and 3. Wait, that was supposed to be in red. 2 and 3. Because they're both positive, they must be the same sign. The sum is positive, so they're both positive sums. We've got those in the denominator. Then we realise, okay, what we've got is effectively an n plus 2 bracket on top, an n plus 2 bracket on the bottom, which means I can cancel those two brackets to give me 1 over m plus 3. Let's try and make it a little bit harder again and go for slightly less obvious numbers. Let's go for a quadratic and a quadratic. So we get r squared plus 7r plus 10, and that's going to be over r squared plus 2r minus 15. So we need to think about, can I factorise the numerator and denominator? We want a product, 10, sum, 7. Right, they're going to be 5 and 2. And that's how I can get that bracket. And we look on the bottom. And the little clue is, whichever one you've managed to factorise already, expect one of these brackets at least to repeat. So we're looking now for a product, which is minus 15, so they're going to be different signs. And we want the sum to be 2, which means positive is greater than the negative part. So we're looking for two numbers multiplying to give me 15, difference, and because of that we're looking for a difference. So two numbers multiplying to give me 15, it's going to be 5 and 3. We know from this that the positive is greater than the negative, so it's positive greater than negative, and now we've got our two cancelling brackets. So I'm left with r plus 2, well, let's take the brackets out first, r plus 5, they both cancel, and that was multiplied by r plus 2 on the top, divided by r minus 3. And in your final answer, you would not like the brackets. There's no way we can cancel these r's exactly as they are. There are some techniques that will take us further, but that's as far as we can go with that one. So let's see more. Let's do one more really grotty one with numbers in front of the a squared. So we've got x plus 5 over 2x squared plus 7x minus 15. Now I know some of you have been using other techniques than what I've been suggesting. I'm still going to quickly jot my grid because of this 2x squared. It's fairly obvious we're going to have a 2x and an x, and we've got 1 and 15 or 3 and 5. Sign there says these are different. Let's go that way. And I also need to do a repeated version of this, but flipped. So I'm now looking for, can I get a value 7 coming out? I'm going to look for, remember the diagonal is that way. So let's look at, I can see where the answer is going to be, but let's try this one. Let's try 10x, oh, it comes out over here as well, and minus 3x. That gives me the right numbers, and it is the correct sign. If this sign had been wrong, change all the signs involved with that side. So I've got the bracket. Technique that people claim is a technique, I am not convinced, is they say we want things to give us 2x squared in the top and minus 15 in the bottom, and then you can try, alright, let's think about the numbers. We've got minus 1 and 15, we've got minus 3 and 5, and you can do the same swaps and tricks, and then you've got x and 2x, and then they try pairs to see what will actually give me my 7x. It is the same as this, but they're not listing everything quite as freely, so you can see everything going on, which is where my problem comes with it. But let's factor, we factorise the top, so we've now got x plus 5 over, and remember the pairing goes, whatever this multiplied must be in different brackets. So I've got an x minus 3 in opposite brackets, sorry, that's not an opposite bracket, is it? So to get the x multiplied by minus 3, they must be in other brackets. And I've got 2x and 5. So plus 5 and 2x. When I look at those two, I can cancel them, and I get the answer 1 over 2x minus 3. Okay, give you some fun, some practice. This whole algebraic manipulation should be, we're going to do one test this week on Thursday, I hope, a simple quadratics. There will be a word question one though, something along the lines of a shape. So you might get a quadratic where you're told the base is 3x, the height is 2x, 3x plus 2, and we'll get told the area is something like 15. Find out how big the triangle is. Okay, that's the sort of thing you might get. So you can remember the area of the triangle. That's going to be 1/2 times 2x times 3x plus 2, and that must equal 15. And we now have an equation that we can solve. So that sort of question might be in there as well. I'll find some examples for tomorrow for you to practice with those sort of shape questions.